Good morning, grade 10. Now let's start question 6 from set 2.1. Question 6 is find the side and perimeter of a square whose diagonal is 10 centimeters. Now see, this is a square ABCD and I have drawn a diagonal whose length is being given as 10 centimeters. Now look at the square very carefully, students. All the sides of the square are equal. So this side will be equal to this side. Alright. Now two sides are equal and each angle of square is 90 degrees. So concentrate on triangle ADC. It is isosceles right angle triangle. Okay. Now if this is 90 degree, these two will be 45 and 45 because angle opposite to equal sides are also equal and it is isosceles right angle triangle. Now we can apply 45, 45 and 90 degree property in this triangle. Now this becomes hypotenuse, which is diagonal of the square. Now what is side opposite to 45 degree? Side opposite to 45 is AD, which is also equal to DC, and that is 1 upon root 2 into hypotenuse as per this property. Now hypotenuse is nothing but diagonal of a square. So it is 1 upon root 2 into 10. Now I want to rationalize this denominator. So I am multiplying both numerator and denominator by root 2. Root 2 into root 2 will be 2 and up I will get 10 root 2. So 2 ones and 2 fives are. So what I get? AD or DC, which is side opposite to 45 degree, which is also a side of a square, is now 5 root 2 centimeters. Alright. Now, once you get a side, perimeter is 4 into side. And therefore, we get 4 into 5 root 2, which is equal to 20 root 2. Please write perimeter of a square is 4 into side. Alright. Now, there is another method also, students. You can suppose this side as x, this side as x, and apply Pythagoras theorem. And then find x. That also will do. Alright. So, choice is yours. There are many methods via which you can do this problem. Okay. Now, let's go to the next problem. Now, look at 7th problem. This is the diagram given. They have said angle F, that is DFE. DFE is 90 degrees given and FG is perpendicular to hypotenuse DE. Looking at the diagram itself, we can say we can apply geometric mean theorem because you have right angle triangle and there is perpendicular drawn to the hypotenuse. So according to geometric mean theorem, you have GF square or FG square is equal to GE into GD. Alright, GE into GD. Remember geometric mean theorem. Now just substitute the values. You have already GF or FG given as 12. So 12 square is equal to EG we have to find out into 8. 8 is GD is given. G to D is given as 8. Alright. So you have 12 square is 144. 144. This 8 will be coming into denominator is equal to EG. If you divide this, you get 8 ones are and 8. 8 ones are 8 ones are 8 and 8 8s are 64. So you have EG is equal to 18. So E to G you got 18. Alright, first answer. Now second C, you have to find FD. FD. Now this is 90 degrees. So this is also a right angle triangle. Alright, which DGF. So applying Pythagoras theorem in this triangle, opposite to 90 degrees hypotenuse, so DF. So you can have FD square is equal to GD square plus GF square. Alright. So you have FD square is GF square plus GD square. GF and GD. See. So 12 square plus 8 square. 12 square is 144 plus 64. You get 208. That is FD square. But we want FD. So you have to take square root from both the sides. Please write here. Taking square roots from both the sides. Okay. So after this you may write. After this taking square root from both the sides. Sorry. Taking square roots from both the sides, you get FD is equal to, now this is square sign has gone and you get square root of 208. 208 can be split up into 16 into 13 where 16 is perfect square. So square root of 16 is 4 and therefore FD you get as 4 root 3. Got it? Now applying Pythagoras, so you got FD. FD we got 4 root 13. Alright. Now, third is EF. We have to find EF. This is also 90 degree, no? So, you can apply Pythagoras theorem in this triangle. So, if this is 90 degree, see this is 90 degree. Opposite to this, EF will be hypotenuse. So, EF square will be GE square plus FG square. So, EF square will be 18 square plus 12 square. 18 square plus 12 square. What is 18 square? 324. And 12 square is 144. Add up this. What you get EF square as? 464. Again, I don't want EF square, I want EF. So what you can say? Taking square root from both the sides. Taking square root from both the sides, you get EF is equal to square root of 468. Split 468 into one as perfect square and another as one number. So 468 can be written as 36 into 13. So what is EF? Square root of 36 is 6 and root 13 remain as it is. So you got EF as 6 root 13. EF as 6 root 13. Is this clear? Okay. Let's go to the next problem. You may pause the video and take down all the steps. Alright. Now, 8th question is just a piece of cake because they have given PQRS as rectangle. I'll read the question for you first. 8th question says that find the diagonal of a rectangle whose length is 35 and breadth is 12 centimeters. So we are drawing this on our own. PQRS as rectangle. All the angles of rectangle will be 90 degree. Length is given as 35 and breadth is given as 12. Now you can apply Pythagoras theorem in this triangle PSR. So applying Pythagoras theorem in triangle PSR, opposite to 90 is hypotenuse. So PR square will be PS square plus SR square. So PR square will be 12 square plus 35 square. 12 square you all know 144 and 35 square I have told you how to find the squares of ending is with 5. First you write 25, 5 square. And which number comes after 3? 4. 3 4s are 12. So 12, 2, 5. Add up this 2 you get 1369. But 1369 is PR square. I want PR. So going from square to PR, I have to take square root from both the sides. So square root of PR square will be PR, which is equal to, what is PR? Diagonal of rectangle. And square root of 1369 is what? 37. So you got diagonal as 37 centimeters. Is this clear? Alright. Now look at 9th problem. This is 9th question. Question 9. Okay. Given is that triangle PRQ with R as 90 degree and M is midpoint. Midpoint means what? RM will be equal to MQ. These both are equal. It indicates M is midpoint. And we have to prove that PQ square is equal to 4PM square minus 3PR square. Now see, proof is easy. Don't be afraid with these numbers. Just see now. First in triangle PQR. This is 90 degree. So by Pythagoras theorem you get PQ square is PR square plus RQ square. So this is your first. Now in triangle PRM. Again R is 90 degree. So you apply Pythagoras theorem in this triangle. What you get? PM square is PR square plus RM square. So you have PM square is PR square plus RM square. But what is RM? RM is equal to MQ. And these both are equal. So RQ is double of RM. Or RM is half of RQ. So for RM, I am writing RQ upon 2. For RM, I have written half of RQ. PR as it is. Is this clear? Now, if you square this term, you get PM square is equal to PR square plus QR square. And this square goes for both these terms. So 2 square will get 4. Now, if I multiply this whole equation by 4, here I will get 4 PM square is equal to, here also I will get 4 PR square. And 4 into 4, this 4 will get cancelled and you get only RQ square. Now you have to concentrate on proof. Proof, we want 4 PM square, I got 4 PM square. But I want only 3 PR square. And here there are 4 PR square. So I can write this 4 PR square as 3 plus 1, which is equal to 4. So I have splitted this 4 PR square as 3 PR square plus 1 PR square. Now this 2 should be on one side, so I am shifting this over here. So I got 4pm square minus 3pr square is equal to pr square plus, see, this pr square as it is plus rq square. But what is pr square plus rq square? See, pr square plus rq square is equal to pq square. So in place of this 2, I am writing pq square. Got it? And that is our proof. So we want pq square is equal to 4pm square minus 3pr square. Okay? You have to think and act as according to what is being asked. If there is 3pr square, I am getting over here 4. I need to split this into 3 plus 1. So the proof becomes easy. Okay? You may pause the video and take down all the steps. That's all from my side for today, students. Thank you.